EGMO 6.
I also encourage people to look at the complex bash solution of AOPS.
Complex bash.
It's incorrect.
Never trust never trusting AOPS ever again.
Is that like a small thing?
It's a very so.
Is this stable?
The thing is, like, if you're constantly intimidated by people on AOPS, then you'll be like, oh, I'm the one who doesn't get it. But if you actually look at what he's saying, then he's the one that doesn't get it.
All right, so we have a cyclic quad.
Circle geometry.
Yes. Alright, so what we have is we have the angle bisectors from all the points. So alright, where do we go?
Emerald.
Useless color.
No.
Yeah, so I think 5 people solved this.
5 people.
Alex, do you want to help him out with that?
Emerald.
I solved more. I solved all of Russia and all of US.
I think 2 people from the US team solved it, 1 person from the Romanian team, and then just like maybe some random.
I swear, like 3 Russians go perfect.
Bro, come on, use Emerald.
Fine.
Yes, Emerald for the win.
Yeah.
Really?
USA won.
What a shame.
How about Russia? Didn't they like?
Alright.
How did Russia get banned?
No, they competed under something else. They competed under
What a
something else,
shame.
and they got like 42, 42, 41.
Alright, so it's like
Now come on,
points.
make it.
I'm gonna stop.
I won't get offended.
Points are
I approve.
X, Y.
I was gonna say, like, what if like they snuck their team members as
Immediately draw straight line.
What did that straight? Alright. So we got this cyclic quad here.
Unfortunately, I don't have
We also have the diagonals.
I don't have
The diagram's getting worse.
So I'll remove the diagonals.
level.
We'll remove the diagonals in a second. 1 second. So this point is P. And
Warning, dangerous bet.
you have the center O, and you want to prove that O,
point?
that's O, that's the center of the circle.
Oh.
You want to prove that these 6 points are.
How did you one shot the
It's 9-point circle, definitely.
Well, I'm just that good. Yeah. I rigged it. So you want to say the question is prove that WXYZP is cyclic if and only if WXOYZ is cyclic. So basically this point the center lies on the cyclic quad if and only if this other intersection point lies on the cyclic quad. Okay, so we'll get to remove those weird points for now. Alright, nice. It's alright now. So what can we do with this? What like we're trying to prove 2 points that lie on some cyclic quad with 4 other points. What should we do with these 4 points?
We proved them cyclic.
We proved these are cyclic. Alright, so that is.
I think you can just do an angle change.
Alright, we will.
This is just trivial angle case.
It's
I
always
was surprised no one pointed this out. Like
similar.
when you prove X, Y, W, Z is cyclic, right? The fact that
Yeah,
it's
this is
cyclic
just trivial.
doesn't depend on
I don't
the
think it's
outer
similar,
quad being cyclic.
but you can just.
Oh yeah.
This is just a sum of quadrilateral.
Yeah.
Yeah.
It's just.
But no one mentioned that. I don't know.
Alright,
So
so
it only relates to quadrilateral.
180 minus.
this is 180 minus
2 of them.
Wait.
180 minus 2 of them.
delta
We have 4 of 180 minus 2 of
gamma,
them.
and this one is the other one.
So it's like.
That would be an
So
O,
it's
yeah.
720 minus 2 of each of them.
So now this is like
Which
these 2
is-
add up to like 360 minus.
360
Which
minus
is 360. It's
which is and then since it's 2 of each the alpha plus beta plus
Yeah.
gamma plus
yeah,
delta.
okay, it's done.
Alright, cool. So now we have that. Okay, nice.
WXYZ.
So this gives us. Okay, I'm gonna remove all of these points for now. Because to
It's
avoid
getting
conflict.
better and better.
It's getting better.
So we know W,
X, Y, Z.
X, Y, Z, always cyclic.
Yeah.
Always cyclic. Okay, so
Independent of ABCD things. I feel like I don't know why people didn't say that before.
alright, so now we have a situation, right? Because now we're like, great, now what?
Yeah.
What the hell do we do with the OMP thing, right?
It does
So like
not matter.
Just through
okay, so for now, let's not worry about the OMP thing for now. It's like, okay, so we have. So can you tell me how? Someone tell me what W is. How W is defined.
It's a point.
Intersection of two angle bisectors.
W is defined as
Incenter, okay, incenter of what?
Of A,
Oh,
B, C, D,
yeah.
and A.
Extend A, B, and C, D. Okay, now
This is
why? When might this be a problem? When might this be a problem?
Depends on whether
Parallel.
which side
Parallel.
or
Yeah,
parallel.
parallel.
Parallel, right? Okay,
Then
so
use the other
Wait, that
one.
was our original P in the complex
Then
matrix.
use the other one.
we call this point
P.
M.
I think if it's,
J,
if
J.
it's parallel, you can still
Okay.
make it.
Okay, so what if A, B, and C, D are parallel, right? Can we just quickly check?
Is this
Wait,
Doesn't
can we
matter.
realize
Rectangle.
Then use
Yeah.
ADBC. Then use ADBC.
It can be a rectangle.
Alright, so
Then
Yeah,
X, Y,
'cause
the
you're just
W, X,
looking
Y,
for,
Z,
like,
the
circle
W,
that's
X, Y, Z,
kind
and
of
O
always exists.
let me draw this diagram. You guys can tell me why we don't have to worry about this case.
It's all good in the hood.
Alright, so this is the so this is gonna be the P point,
It's because it's symmetric.
and then we're gonna draw in the sum of the angle bisectors. So
It is all
What
good.
color is that?
With
Oh,
stereo.
because collinear would.
Yeah, they're
Oh,
all.
it would never be. Oh.
alright,
Oh,
So,
that is true.
what do
That
you
is-
see a problem here?
Yes,
That
collinear
is
is also
true.
never.
When it is a isosceles trapezium, when two sides are parallel, two sides
Parallel.
parallel,
Well, technically that can cyclic collect.
When four
You
sides
get-
are parallel.
you get 4 points collinear, 4 points
for Mass Olympiad.
collinear. So it will not be cyclic. So it cannot be cyclic.
They have to show that like it's
Yeah.
bad if like W, X, and P coincide. 'Cause then it's only two.
Wait, technically it's cyclic.
What
No,
is
it says
the
assume they're
circle's
distinct.
just a
I
line.
think. I think it says assume they are distinct.
Okay, that would be the most annoying.
Yeah. So yeah, when you have this case, these 4 points are kind of collinear, so obviously they're not cyclic. So we don't have to worry about this. In particular, no 3 of them can be like cyclic. So you can't have like like W and Z, W and Y, and like O being cyclic, and not with the other one. So you don't have to worry about that. That means we can just assume that they do actually intersect. And so we can do the same on. Okay, so we'll intersect this for now. All right. So we know that W is incenter
Oh, ADM.
incenter of ADM. Okay. So W is the incenter of ADM.
Alright.
Incenter.
Okay, now do like
Whoa. What other point?
M.
X.
Okay, maybe not X yet.
Y.
Wait.
So let's just draw in this, right? So this is supposed to be the. I have Parkinson's. Okay. So
Would be a series.
this is the incenter.
Mhm.
So what other point? So I've said this W point. What other point might be suspicious then?
Y. Z.
Y.
X,
Y.
X,
Y.
Y.
Oh,
Okay.
X and Z are symmetrical.
yeah,
so
Y
it's
is the X center of MBC.
Oh, Y is the X center.
M X center.
Oh.
Y is M X center.
I thought this is different to what
X center
I heard.
of
There's quite a lot of different solutions from what they were talking about.
MBC.
Dilation time.
Okay.
Let's go. No.
So what we can do here is what does that tell you about M, W, and Y?
They are collinear.
Collinear.
Yeah.
Oh, wait, no. I think it's.
And their midpoint.
Can I just
the midpoint of WY is the
I'm going to attempt 2/3 coconut.
let me just use a ruler for this because that's not a
Wait,
ruler.
no, that's erase a rule.
1/3.
Oh, is this the
Yo, I'm so good.
Wow.
Oh,
Wow. Not assisted. Not assisted.
No, but they're actually collinear though.
Yeah.
Okay, anyways,
Oh yeah, actually yeah.
But nah,
all right,
look,
so
M is
maybe
kinda
we can
sus.
do a bit of a chasing of the angles.
That is too hard.
All right,
I give up.
let's just do. We're gonna call this. Yeah, we're gonna use some of the angles again. Alpha.
A, B, C. Alphabet again.
Okay.
Like an angle
Can
with
someone
column
tell
and
me
like-
some more angles?
Not
Wait, what's our goal here?
I need for complex something.
Do we just
Chase a few angles with the
label
two.
every angle possible?
Sure, let's do that.
Okay,
This
W is 118.
Can someone tell me what this one is?
2 alpha.
that is yes.
2 alpha. Okay. Actually, yeah, sure, whatever. It's
That
fine.
is too beta. So.
To alpha.
C,
Okay.
C is 2 alpha.
C. So okay. So
BCD is 2 alpha.
Wow.
I mean, see what the important one
And
is.
that is a similar
Image
triangle.
gammas.
That is a similar.
BCD is 2
triangle.
alpha.
Okay. So can someone tell me what this is?
19
What is that?
That is a
minus
beta.
I can't
Alright.
read the diagram. I can't read the diagram.
Don't worry.
It was like a very bad. The answer was like a very bad.
All right. Now can
Alright.
someone tell me what this one is?
90
So 2
minus
beta,
90 minus alpha minus beta.
Minus alpha minus beta. Okay. So what is this? What is angle BYM?
Oh my god. B
Two
Y.
alpha. Alpha plus beta.
1 alpha.
Is equal to 1 alpha. Okay.
A singular alpha.
All right. Now what's some?
Even the equal sign is sad.
The equal sign is sad.
It looks like a sticky face now. Look at the sticky face.
All right, guys. So this is alpha.
What did you do?
All right. Anything sussy?
So 10 the same.
What? Lucas said it.
Whoa.
BAYW.
Yeah.
Yeah.
Why?
Because you got 2 alpha subtending the same chord.
So BAYW is cyclic.
Amazing.
Oh yeah, I remember.
That is so
It's like some. I don't know.
And then symmetry
I wouldn't
means
get
the
it.
other thing as
Okay.
well.
So now we're gonna let's just draw a new diagram, shall we?
Why?
Symmetry doesn't the other
Alex,
side.
go help him.
Draw that. I was like,
Alex will carry the whole diagram for you. Yes, Jules? Yeah.
Wait, hold on.
kind of crazy.
Yeah, this is where they need to interview the contestants and be like,
Wait, what?
how long is it going to be the first 2
What was that? God, what is happening?
How many did you have left to solve?
Oh wait, what's happening? Are you gonna keep
I
going?
drew a circle. Yeah, that's it. I don't know. I'm not
Okay,
bothered.
Thank you.
Oh,
Whoa.
Whoa.
Right, that circle is clean.
yeah, because he used
Circle tool.
Maybe you should use a line tool as well.
Slightly.
No, this is what happens when you guys have bad habits.
Oh.
And then
But
you guys.
you get access to a ruler in the exam.
Do you use it though? That's the question.
Yes.
Oh yeah, I don't. Good point. Good point.
He doesn't use a rule or a compass.
Yeah, I don't use a compass either. Freehand.
Well, that's
Yeah.
what I'm doing now.
I use
To
the ruler,
simulate
but
you
it's
in the
not
exam.
helpful.
Simulate exam.
Simulating exam conditions.
Eggshell, let's go. Eggshell, let's go.
Nah, alright, I understand now.
And
Hot pink.
Periwinkle.
Hot pink.
Eggshell.
Oh my god.
Eggshell with dark mode on.
well, let me think. How do I do this?
Yeah, that is the way to use hot pink.
Hot pink.
Yeah. Hot pink.
Would you like to try it?
Really?
I'll give you one, yeah.
Thank you.
All right. Well,
Why do those two colors look suspicious?
Why was it
The
big
same.
giant?
probably because I use the same colors, anyways.
My
Okay.
God.
Yeah.
A, B,
And it saves forever.
C, D.
Oh, I got 2 feedback colors.
This one's really good.
Thank you.
All right. So someone said something about extending to the other side as well.
Oh yeah. Yeah.
Yeah, Menelaus.
That's a complete quadrangle.
Stop, please.
It's harmonic.
You can have that.
remembering the projective.
Wait, what?
I love harmonic.
All right.
Wait,
Bro,
Yeah.
the BC extension kills me.
That's like a geometry configuration.
Possibly.
Not very useful.
Like those
It's one
four-
star. It's one star problem solving tactics.
The 4 circles that intersect at one point.
Oh, Miquel Point.
Yeah.
Oh yes, something like that.
Oh, Miguel Point. Oh, I remember.
All right, so let's just talk you through something here. Okay.
Is it
So what do we have, guys? What do we have from before? We have A, B, C, D cyclic.
Do you remember?
A, B, C, D. What else are cyclic?
W, X, Y, Z.
Anyone? Anything else?
WX.
What was it like? A, X, W, D? Yeah.
And
Or bird.
WY.
A, D, Z, X by symmetry. These are all cyclic. Okay. Now I'm gonna.
The other
CY.
side.
And
yeah.
furthermore, we have that these 3 points are collinear. Now this is going to be difficult because I have Parkinson's. I'm going to use my other hand to stabilize it.
Well, stop having Parkinson's.
Okay. And MW Y collinear.
Is this project?
Nearly.
This
Oh.
is 3D geometry.
All right. So,
Oh, 3D.
what can I do with this thing? And let's see. Wait, is that used? Yeah. This thing, and this one.
Smash them together.
The next point.
They all have
like,
common points.
Common
Common
yeah.
point?
Yeah.
Oh, right.
Wait.
Rat. Something.
Radical
How do you do
Radical axis.
radical axis?
So-
wait. What are the common points?
His
So,
hangman is faster
those
than
two
your
have two
Theorem.
common points. I don't know anything
Wait,
else.
AB and WY intersected
AB is the
CD
AB,
and
WY,
is the
Wait,
radical
what?
axis of AB,
X, Z,
and
doesn't
Y.
work. God
Okay. So.
The radical axis.
What's that for?
Radical
N
axis,
is
yes.
collinear
Radical
with Z
axis
and
of
X.
ABCD and WXYZ.
So
It's
think.
intersection of
N, Z,
all,
and X are
and
collinear.
it's
So
intersection of
I believe.
like WY and XZ.
So the question
Yeah,
is,
the radical center.
That's the radical center.
which one's the
Oh,
radical
Those
center?
three.
That's big. That's
Okay,
big.
so something like that. That's
Huh?
yep.
Yeah.
Okay. Anyway, so that's not okay. So main two circles I want you to look at with respect to M, the first one and the second one, and tell me about All right, someone tell me the power of a point from M to the first circle.
M
A, B,
to
C,
the
D.
Yeah. So what's the power of
Rounded right.
MB.
M A M B.
M A? What about the other one? To the small circle.
M, C,
MWM.
M W
W and Y.
dot M.
Oh yeah, the
Y.
second one.
All right. What is this?
Oh, it gives us similar triangles.
Not quite,
Oh, wait.
but not exactly what I'm going for. But
Oh, wait, no, no,
Inversion. Is
no.
this inversion?
so
Do you
how can we relate these two? Possibly using the third quadrant, second chord I mentioned.
M B.
BWY.
This is cyclic. Is
They
that
do not.
So those three ones I've circled over here.
wait, WYCD is that
WY.
because then you also get
Oh,
this times this equals
Oh,
this
I
times this.
see.
And then
Yep.
that's cyclic.
Okay.
Yeah, so-
this is the power of A. Okay, I see.
So okay, so these two powers are equal.
Damn.
Yeah.
Okay.
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 What about what can we say about N?
And
N.
And it's sus.
I believe that N, Z, and X are collinear.
Yes, thank you.
Yeah,
And then?
NZ times N. Oh wait.
Okay.
Yeah, NZ times
Wait.
NX equals ND times NA.
Yeah. So that means the power of a point of both circles are the same at points M and N.
Oh.
What does that tell you? So
So that is the radical.
top
wait, that is the radical
of
axis. That's the radical axis.
A, B, C, D,
Wait, bro,
and
you're literally on
X,
KFC.
W, Z, Y are the same
Taiwan, so.
Yeah,
at
that is true.
N,
M.
and then.
Yeah, like
And
M is
N.
the radical center of those three. Like N is the radical center of those.
Mince. Sonic.
Oh damn.
All right. So
Right.
what does that tell you about MN? MN.
MN is the radical axis of those two circles.
Yay.
Wow.
Only drink Coke.
Let's go, boys.
All right. So now comes the. All right. So MN is the radical axis, and okay, now we're gonna bring in the other 2 points.
Oh no.
Oh.
I don't like the other.
Oh
two.
no, it's gonna
They
get more
suck.
than your zero grade.
Alright, so we're gonna just go
Okay, let's see.
Okay.
So
Alex,
O
if it goes
is
back,
just the
let's use
center.
it.
All of this is motivated.
Yeah.
All of this
Oh,
is
pickle.
automatically motivated.
Pickle
Wait,
color.
what?
Wait, bro.
Cool.
Pickle
This is
color.
Eggshell.
Alright,
No.
so this is
Oh
gonna
my
be
goodness.
Those lines are
That's
P.
P.
and this P and
The
O
O
is
is center of the circle.
O is somewhere over here.
Oh,
What
damn.
happens if we actually use the rules
Alright,
on top
so
of the laptop screen? Would that
What do you
work?
suspect we might want to do with these 2 points?
Equate their radical. Wait, equate their powers or something. I don't know.
Oh wait.
Yep.
Like
Never
can,
mind.
Equate their powers
OP
in
intersects
some
MN.
way.
OP intersects MN.
Such
Okay.
that like when one is 0, the other is 0 or something.
Okay. OP intersects MN. So
Wait,
this is S.
hold on.
All right.
Hours.
What's the power of? Well, I guess what's the power of those 2 points? I guess.
Wait, I'm confused.
Well, what's the power of point with respect to the big circle? Well, actually, no, not yet. So what's the power of what's the like? How do we say this?
What's S again?
S is when you intersect OP to MN.
Hmm.
Oh.
So like, why did we do this? Why did we want to do this?
Because if we show that the SP times SO equals like the power of
Yeah. Okay. So SP
usually the big circle because like that
Times.
seems better
SO
equals the power of S in respect to ABCD.
is equal to
Isn't it
power
a little circle, but I guess it's the same.
Yeah.
of the little circle, right? So okay.
Which
So
is
let's
also
just
the big circle because it's on the radical axis.
Today
It's on the
into a
radical.
radical axis.
Yeah, we are all
Indeed.
identical.
yeah.
Equals
Well, it's
We're
not
S
exactly
one
the
over those two are, okay.
it's not exactly the big circle,
Oh.
yeah,
Interesting.
because
Interesting.
all right. So we can write this as S. How did this go? It was like SO times SO minus OP
OP.
equals
That's
to
OP.
SO squared minus.
Minus.
Okay,
Oh.
so when
SO times OP. I have to get that.
Naruto is
other
psychic.
yes.
yeah, so if we think about this, SO times OP. So remember, so this thing. So we're supposed to have both of those points either on the thing
Circle or both not.
or both not on it, right? So this is the power of a point from S to the small circle. So from S to small circle.
Pop.
It's assuming P is on the small circle.
If P
So
is on
we're-
the small circle, O is also.
So
on
yeah,
the-
I guess like when O and P are on the small circle, this would be the power of a point.
Oh, okay.
And when that's the case, like so when that's the case, we know that the power of a point to the big circle should also be
The same.
the same, right? So what should that tell you about this in terms of perhaps like
It's equal to radius squared.
yeah, so this is this so we kind of want
KFC.
Yeah, this is
SO times OP
Very rigorous language.
equals to R squared, where R is the radius of the big circle.
Wait, is kind of want actually equals to need?
If we can show that it's always this, then we're done, kind of.
Yeah, like it suffices to prove. It's required to prove this.
Yeah, pretty much, I guess.
So need.
invert about the
Yeah.
circle. I did
Okay.
not goes up to P.
So we want this, and how do we get this? There's a step.
Wait, I'm a bit confused.
Okay, so basically, you want to like that when this is on the circle, you need the power of a point to be like. You need the power of a point to be SP times SO
That's the power of the little circle, yeah.
in the little circle.
But since S is on the radical axis, it's got to be equal to the power on the big circle. And the power on the big circle is just the distance from the center squared minus the radius squared.
Yeah.
And so
Okay.
since S, so yeah.
Oh, yeah.
Okay, so this what so Lucas said something before. What is this? What does this look like?
Cycle.
Inversion. What? Inversion.
Cycle.
So inversion. What else is kind of like inversion?
Similar triangles.
Dilation.
So
Dilation.
Projective.
projective. All right. So let's think about
I
what.
texted you at like 9. I texted Mommy at like 9. So, yeah.
Who are you talking to?
Yeah.
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 Is Lucas talking to us?
He's calling
No,
us.
I texted my mom at 9. It's like Michael speaking me out.
Oh, and she's here anyway. Oh, really?
No, my brother called and said we're having dinner. We're eating dinner out.
That's so tiny. Okay, so
Unlucky.
projective thingo. So well, what actually happens here is we're trying to say that so we can kind of rephrase this, right? So we can say if we project P, the projection of P with respect to the circle is actually the line MN. So this actually leaves us with like
Wait, and then.
Wait, you're saying the reciprocation of P is so like the polar of P
yes.
is MN.
Wait.
Is that man?
Wait, but
this
is that
the
a
way
right
to do
angle?
that projective geometry?
This last part is a bit like,
Projective geometry
we can
is
explain
just
the projective
sim,
Okay,
except
yeah.
it's finer than
Anything at
except
all.
generalized.
yeah. This part is where the proof, the solution said it is well known that the triangle PMN is autopolar, and so we have these solutions. But we're gonna go explain.
Self-polar. Yeah.
Well, no.
It is well known that.
Oh wait, right. You
Yeah.
saw that in EGMO.
Oh, it actually is.
Yeah.
Yeah, I said.
Yeah, I taught this to Alex at least
Yeah,
All right, so
recently.
I see.
we can reasonably
It's
do it
well
using
known.
It's not the harmonic quad. What do we do?
Not really.
Oh,
I
basically.
don't know much about any of that.
Oh, okay. So I'll just explain what it is. Reversion is basically a reflection about the circle.
Autopolar.
Okay.
Yeah.
Yeah.
So
Damn.
So like goes onto the point
Okay.
opposite the circle.
yeah, so like
Okay, we're done.
the image is always in line with the center. So you
Oh.
draw a ray with the center. So the inside of the circle goes to the outside of the circle. And reciprocation is like instead of taking the point to the point of inversion,
Wait, this is just EGMO.
you take the point to a line.
Yes.
And so,
A
so
lot
the
of
whole point of
EGMO.
projective geometry is there's a sort of a duality between point and line.
Oh.
So inversion is a function from points to points,
Yeah.
and the reciprocation is a function from point to line.
Okay.
All right.
So that's what poles and polars are. So poles
Oh.
are points.
Wow.
The
I
I
still
need
have
to
to
read
read
EGMO
Oh.
again.
I dropped out. I stopped
Point.
reading
Yeah,
the
okay.
angle, the chapter before Paul.
Oh no.
Keep this out.
Okay. Anyways,
Keep this.
so we're gonna have to kind of just how do we say this? How do we?
Just
We're
kinda
gonna
you can ask about like
some stuff we can kind of have to assume. So for example, if I drew in this, there is a certain name for a certain configuration called Chaver-Menelaus.
Metal
So some of you guys might have heard it.
Ah,
Seven?
I know.
Seven? Seven.
Alright.
Oh my god.
And we call this like F and G, I guess.
Yeah.
Lucas is such a simple.
Oh.
Lucas is just
Lucas is chill until he hears this.
Basically, so it's like how it works is if you know Chaver, it's like if you know Chaver, it's like
ADGN, it's
ADG
harmonic.
Chaver gives you that the sides like multiplied nicely. Menelaus gives you the other some other sides multiplied
like
nicely.
The moment he hears,
And
projected
when you
stuff,
combine
it's
these,
like,
you actually get up there like
just goes higher.
these 4 points have a certain property that
Collinear.
they are collinear indeed, almost as if we define it as that.
Cross ratio.
Anyways, it gives you that this thing has a nice ratio, and when with the ratio, how it works is like A, B, C, D. So we'd have like the ratio. So you take the pairs A and C and B and D. So it's like A, C, and semicolon BD. And the ratio is kind of defined like you take it from 1 to 1, and then you take the other side so it's like AB and CB, and then AD and CD. So you take this with this, this with this. So it would look like AB over CB over like AD over CD. And the ratio of this, normally, like if you use directed length, it'll be -1. In this case, we don't really care, so we just call it 1. So you can get that using Shaver and Menelaus together.
It's harmonic.
In an
So
uncommon
severs and
Harmonic
formula.
mental.
Yeah, no, that's.
Oh, that's
Okay,
Okay, that's kind of all you need. That's all you need for this. Okay, so we have. So using this, which 4 points do we have harmonic? Which using this using that configuration? Be not necessarily ADGN, right? Yeah. So if we use AMD as the triangle, and then we have the AGDN is kind of the harmonic thing. Now we can actually okay, so now we can actually send that through. We can project this the line AGDN through M onto the line BN.
Oh yeah.
So that actually
Yeah.
Actually,
Do you think the
first
OP is
question.
perpendicular?
yes.
VFCN then goes on to wait no.
Okay, so we have now with that like AD GN
E, the polar,
and MBC
so if you draw OP to
BCFN
right angles.
are harmonic.
And OP times that point of
Okay, and there's a thing with
is equal to the radius squared.
there's a certain thing with harmonic quads, well, with a cyclic quad and harmonic things. So it kind of goes like,
You need so much theory for English.
well, no, this is all going into proving that one thing, which
Yeah.
could arguably is arguably just
So
claimed.
MN being the polar.
This is just a reading EGMO.
Yes, it is instructive.
Read EGMO, just do EGMO.
All right, so how does this go? It's like
Hold on, sorry. Like
Read
the
EGMO.
definition is you take the
if you have
and then you take the line 9 degrees to the radius.
Okay.
So that's the line.
No, like you have egg and then you have
Yes,
this.
Look at my previous proof.
And is the line that
I want to
all right. So now it's like okay, this is it kind of gets out of hand, but I'm sorry about
This
this.
is getting out
But
of
it's like
hand.
when you have a circle and these 2 points, okay, so the pole. How do you define this? It's like if you have a point here,
Wow.
this is point P.
Oh,
So
and then it's the polar
AOP and
P.
the intersection.
If you have like, what you do is you draw the like perpendicular,
And then,
and then you draw the
basically
tangents.
an inverse.
You draw the tangents, which means kind of like here, right? And then you draw this line here.
Mhm.
This line is the polar of point P. And
And then
here's the thing. It's like if you have 4 points are harmonic and 2 of them lie on the circle,
Yeah.
then you actually have that that point outside the circle actually lies on the polar of C. So that can be
oh,
proven in
That can be proven.
that can be proven probably just by angle chasing. I cannot think of how we'd do it now.
I don't want to do
But
it.
yeah, anyway, so that exists. And
Yes.
also, this one kind of looks slightly more obvious, but oh yeah. So also with the polar thing, you can also have a point that's outside, so like Q.
yeah, and
And
then it's the line that double yeah.
It would be like this line. That would be the polar of Q. And so you can actually do this with similar triangles, but it's like if A lies on the polar of C,
then C lies on the polar of A.
then C will lie on the polar of A. And this one is actually reasonably not that bad to do, if I recall. It's like because you have cyclic quads here and there,
Yeah.
so you can just kind of do it in your own time.
Yeah.
So using this
Proof is left
in applying this to
exercise.
here, what do we have? Well,
AOP.
so we have that these 4 points are harmonic. We have these 4 points are harmonic.
Yeah.
So what does that tell you? So that means the
F is
the polar of this must
is-
pass through G, and the polar of N must also pass through F.
Oh, that is the polar. Wait.
So that means that the polar that
Is
it has to be
MG.
through like P here,
Mm.
and then
the same and
I think you can just that basically gets you that this is
on the polar.
so it's like on there. This is on the polar of this, and also I think you can do you can do the same thing, and similarly it's true for M. So it's like this is kind of both of these are on the N is on so P is on the polar of N. P is on the polar of M, which means M is on the polar of P. N is on the polar of P.
Oh, so MN is the.
So Mn is the polar of P.
Yeah.
Okay, so that gives you that this is actually polar and this is 90 degrees.
Yeah.
And
and
so
then
we
it's
get
not-
that. Furthermore, we get that this thing here times this thing here is actually
Wow,
r
radius
squared.
Yeah.
And so instead we can have this first and then put it into here. So it's like in some sense we know that so like if we just look at this,
Fact.
if P is like
That's satisfying.
yeah, so this gives us like so we have this and now we have it's like if P is on the circle, then if we just take a look at this thing, then we actually get this thing which is equal to SO squared minus R squared. And that tells you that which is the same as the like power point of the big circle. And so it has to be the same as the power point of the small circle. And since P is on the circle, that means O is on the circle.
Dude,
And if you go O is on and same thing with O is on the circle, then P is on the circle.
Oh, was it infinitely?
Yeah.
Yeah.
So yeah, that's how you. I guess the first part it's kind of like motivatable. You guys said Excentre, Incentre, then found the thing, possibly the radical axis, and then I guess after that, this is like if you know this, if you know this like so it's like now from now on, right? If you see a question that's like circle, quadricyclic quad, intersections, O, and if you see intersection and O as well, and possibly involves extending lines, you know what? Like you'll think of this, right?
Yeah.
So it's like if you know the thing, and you saw this problem, and you got up to like the cyclic quad bit, you probably like think of it because after you get like this cyclic quad, because after you construct these 2 points, and you find the two cyclic, you don't even need to find the two cyclic quads yet. You'd already think of just doing this. And then from there, you would think of like just using this and then you'd like look for that cyclic quad to find like, you think of using radical axis in some way. Because using power of point, because you know that SO times OP is equal to R squared. So that is how I guess you would motivate this. And now you've learned a new thing.
Yay.
Yeah, so just going back to this thing.
So the reciprocation thing is chapter 6 of Geometry Revisited.
Geometry Revisited. Okay,
So it's the very last chapter.
It is.
I forgot all of this. I
It's
forgot
in-
all of
It's
this.
also somewhere
I
in the
forgot everything.
Chapter 9 of EGMO.
Chapter 9
Chapter
is
nine.
Why does geometry require so much
Euclidean
theory?
complex
Complex
mathematics.
Oh,
I'm
is
going.
that-
I
yeah,
want to
you
check
remember
the
this
from
page?
third sounds
Yes,
way.
and it's got father from Kansas.
Project geometry, complex dash.